In this video, we're going to go over trig substitution. So instead of having let u equal some function of x, we're going to have x equal some function of theta. So we have the integral of f of a squared minus x squared. So the substitution you would use as x is a sine theta. So if we have the integral of f of the opposite, so x squared minus a squared, you would substitute x equals a secant theta. And the integral of f of x squared plus a squared, you would substitute x equals a tangent theta. So the reason this works is because, let's say for this, the first identity, or the first substitution, if you plug in a sine theta, you'll get a squared sine squared theta. You'll get a squared minus a squared sine squared theta. This is x squared. And you can factor out the a squared, so you get a squared times 1 minus sine squared theta, which is just a squared cosine squared theta. So that can simplify a lot. For number 2 case, you have the inside would be x squared minus a squared. And if I substitute x equals a secant theta, you get a squared secant squared theta minus a squared. This will be a squared times secant squared theta minus 1. But this is just tangent squared, so this is a squared tangent squared theta. And the third case is here, x squared plus a squared. When I substitute a tangent theta, you'll get a squared tangent squared theta plus a squared, which is a squared times tangent squared theta plus 1. But this is just secant squared theta. So we can really simplify a lot of integrals. So let's say we have the integral of 1 over square root of 1 minus x squared. And this standard result is just inverse sine of x plus c. But the other way of getting it is let x equal a 1 times, this is a squared, times sine theta. Dx is cosine theta d theta. This will be the integral of cosine theta d theta over square root of 1 minus x squared, which is sine squared theta. So this will be the integral of cosine theta over, well, this is cosine squared theta. So under the square root, you'll just get cosine theta, which is just 1. So integrating that with respect to theta, you get theta plus c, or you get, so solving for theta, you get theta is inverse sine of x. This will just be inverse sine of x plus c, and that's the same result as before. So that's the end of the video.